Hi students, we are discussing contact forces. So far we discussed normal reaction and tension in the string, okay, and spring force I discussed. Then another force is frictional force. It is also a contact force. When two bodies are contact with each other, when two bodies are pressed together, that means one body tries to slide over the surface of another body, then this frictional force arises, which opposes the relative motion between the blocks, okay, which opposes relative motion between the surfaces. Such a force we can call it as frictional force. Frictional force or simply friction. So how do you define this frictional force? When two bodies pressed together, when they try to slide over the surface. When two bodies pressed together, when try to slide over the surface, then frictional force arises. Okay, so it is a contact force. It is a contact tangential to the surfaces. Contact tangential to the surfaces of contact. So how it will act? It is tangential to the surfaces of contact. Such a force we can call it as frictional force. What it does, it opposes the relative motion. It opposes the relative motion, not motion, okay? It opposes the relative motion. So such a forces we can call it as frictional force. It is a I will try to explain with the help of this example, okay? So let us consider a block. I will draw the diagram here. So this is a horizontal fixed surface. Let it be a block, okay? Now this block is placed on a horizontal surface. What is this? Horizontal surface, rough surface. So what are the forces acting on this one? Weight downwards and the normal reaction acts upwards. So this weight balances with the normal reaction. So when there is no external force acts on the system, the block will be at rest, okay? When the external force acts on this system, so this is an external force. let F be the external force acts on the system. So what is F here? F is let M be the mass of the block, mass of the block, mass of the block placed on a rough horizontal surface, rough horizontal surface. Okay, so let F be the external force acts on it. Let F be the external force acts on this block. So what happens? The block may or may not slide. Okay, when this applied force gradually increases, it opposes this, its motion is, this block is trying to slide over this surface. Then this friction arises. That friction, it is acts tangential to the surfaces of contact, and that friction is represented with letter F. It opposes the motion of this block, relative motion. Okay, so when this force gradually increases, this frictional force is also increases, and at a particular instant of time, this F exceeds this frictional force value. This block slides over the surface. Okay, so this F force gradually increases on the block. Let F be the external force. So as external force increases, as external force gradually increases, the block has a tendency to slide. Block has tendency to slide, isn't it? As external force gradually increases, the block has a tendency to slide. So when this applied force, as applied force increases, external force gradually increases, the block has a tendency to slide. The frictional force is also increases. Frictional force also increases. Okay, so frictional force is also increases. This type of friction we can call it as static frictional force. So this frictional force is two types. The first one is static frictional force. So what is that static frictional force? Static frictional force. So the first type is static frictional force. The frictional force between block and the surface. Frictional force between block and the surface. Block and the surface when it is in static position. When it is in static position. Static position. That means still it will be at rest. Okay, so when the block is in static position, the frictional force between the block and the surface is called static frictional force. This static frictional force value increases with applied force. So if you draw a graph between, see, this is a frictional force. Frictional force I represented with a small letter F, and applied force. So this is applied force, capital F. This is capital F. So you draw a graph between this frictional force and applied force. As applied force is 0, there is no applied force here. This friction is also 0, isn't it? When there is no external force, the frictional force is also 0. So when this frictional force comes into action, when this external force gradually increases, the frictional force comes into action. Still the block will be at rest. This then it opposes its motion. That is, opposes this frictional force. It opposes the motion of this block. That's why it acts opposite to the external force. As this applied force increases, the frictional force is also increases gradually. Okay, so up to certain instant it increases. So that is called limiting frictional force value. Okay, so the maximum value of static frictional force is called limiting frictional force value. So what is the limiting frictional force value? Limiting frictional force. So the maximum value of static frictional force. The maximum value of the static frictional force. Static frictional force. Frictional force is called limiting frictional force. Okay, so after that, during this, meanwhile, suppose at a particular instant of time, here the applied force, let it be capital F. If it is less than that, suppose meanwhile between this value and this, let it be represented with the letter 0 to A. This limiting frictional force, I take it as the point A. So this value, this is I take it as A. So I draw a perpendicular on this line. So this point I take it as OP. So this applied force, if it is less than this, between these values, then the value of frictional force is, static frictional force is equal to applied force. Okay, so when the block is at rest, when the block is at rest, when the block is at rest, the frictional force value, frictional force is equal to applied force at that instant. Applied force at that instant. Okay. So frictional force is equal to, when the block is at rest, the frictional force is equal to applied force. So you have to notice this point. At that instant, you are applying the force, still the block will be at rest. Then what is the frictional force between block and this surface is equal to applied force. Okay, and this, after reaching this maximum value, static frictional force, okay, after reaching this maximum value, at that position the block has a tendency to slide. So at this position, the applied force, the block has a tendency to slide at that instant. Once it starts sliding over the surface, then the frictional force value decreases a little bit and then steady. It will be like this. So as the applied force increases beyond P, the frictional force value decreases. That means the block starts sliding. So then that frictional force, we can call it as kinetic frictional force. It is represented with letter Fk. This static frictional force is represented with letter Fs. Okay, so what is Fs? Limiting static frictional force. When applied force exceeds the limiting value of frictional force, that is Fs, maximum value of static frictional force, exceeds the limiting value, the block slides. Then frictional force between block and the surface, is called limiting frictional force. Is called kinetic frictional force. Okay, so this is the definition of kinetic frictional force. When applied force exceeds the limiting value Fs, the block slides. Then frictional force between the block and the surface is called kinetic frictional force. It is represented with letter Fk, or dynamic friction. It has another name, dynamic friction, that is in motion. So this frictional force value, kinetic frictional force value, it is less than limiting frictional force value. So this kinetic friction Fk value less than maximum value of static frictional force. It is less than static frictional force. After further increasing this force, applied force, the kinetic frictional remains the same. Further increasing the applied force, Fk value remains the same. Fk value will remains the same. It won't change. Remains same. It remains constant. Further increasing this applied force, that is capital letter F, Fk value will remains same. Okay, so these are the two types of frictional forces. First one I explained the static frictional force, second one is kinetic frictional force. So what is the static frictional force? The frictional force between the block and the surface when it is in static position, that means at rest. Further, when this applied force gradually increases at a particular limiting value, the block ready to slide. Okay, after if it exceeds that value, the block slides over the surface. Then the nature of the frictional force between the block and the surface changes. That will become kinetic. Its value is less than static frictional force value. Okay. Now this limiting frictional force value and static frictional force value. Now this frictional force value depends on what values? That is called loss of frictional force. Okay, so I explained two types of frictional forces. Then loss of frictional force. So this loss of frictional force. What is this loss? The number one is frictional force. Frictional force is directly proportional to normal reaction. Okay, this is the first law. So frictional force is represented with the letter small f and the normal reaction is represented with letter n. So F is equal to, if you remove this proportionality, you have to write a constant, that is mu into n. So the frictional force is given by the formula mu n, where mu is called coefficient of friction. Coefficient of friction. Okay. So this coefficient of friction, it is defined as coefficient of friction mu is equal to, we can write frictional force by normal reaction. So the frictional force, this coefficient of friction, we can define as coefficient of friction is defined as the ratio of frictional force to normal reaction. That ratio is called coefficient of friction. It is represented with letter mu. So mu is equal to, is given by the formula, frictional force is F, normal reaction is N. So mu is equal to F by N, or F is equal to mu N. What is F here? Frictional force. Okay. So the frictional force is given by the formula F is equal to mu N. You call it as equation 1. This is equation 2. Of course, both are two same. Okay. This frictional force mu has, it is a dimensionless quantity. Mu has dimensionless quantity. Dimensionless or unitless. It has no units and dimensions. It has no units. No units. Because frictional force is measured in newtons, normal reaction is measured in newtons. Newtons get cancelled. So mu has no units. So it is a number. Its value lies between generally 0 less than mu less than 1. That means its value lies between 0 and 1. 0 and 1. For smooth surface, we can take it as, zero. Frictional force is 0. Frictional force is 0. Okay. For smooth surface, mu is equal to 0. And for mu greater than 1, it is sometimes on rare occasions mu greater than 1. That is occasionally. Okay. So there are some exceptional cases that mu greater than 1. Is it mu greater than 1? For that answer, you have to answer yes, sometimes. Okay. But generally, the mu value lies between 0 and 1. This mu value depends on nature of the friction. Okay. Mu depends on the nature of the surface. Nature of the surface. Mu independent of frictional force and normal reaction. Frictional force independent of normal reaction. Normal reaction. Okay. That means weight of the block. What is normal reaction? Nothing but weight of the block or mass of the block. I will write mass of the block. It is independent of mass of the block. It depends on nature of the surfaces. Okay. As frictional force is doubled, normal reaction is also doubled. But mu value remains same. Suppose if you keep another block on this, what happens? Weight becomes double. then normal reaction is also doubled, but mu value remains same. Okay, that is the meaning. And this is mu value. And the next one is, this is regarding mu value. Okay, the next point is, if it is a static frictional force, so we can write it as static frictional force. Static frictional force is directly proportional to normal reaction. Normal reaction. So similarly we can write. So Fs is equal to mu Sn. Okay. So this is the value of static frictional force value. Similarly, kinetic frictional force value. Kinetic frictional force. You want kinetic frictional force that is proportional to normal reaction. Normal reaction. That is also. But Fk is equal to, while removing the proportionality, you have to write mu k, suffix k, into m. What is Fk? Kinetic frictional force value. What is Fs? Static frictional force value. What is mu s? Coefficient of static friction. Coefficient of static friction. What is mu k? Coefficient of kinetic friction. Kinetic friction. So generally mu k less than mu s. That is Fk less than Fs. Okay. These are the two types of frictional force. So when the block is in motion, you consider kinetic. When the block is at rest, you consider static frictional force. Okay. So this kinetic is less than static frictional force value, since mu k is less than mu s. Okay. And one more law is, this is the next, these points we can call it as laws of friction. Okay. The next point is this kinetic and static frictional force value. Static and kinetic frictional force values. Frictional force is independent of area of contact. Area of contact. So whether the block is placed like this, suppose there is a brick, this brick having the mass m, it is placed like this. Okay, then the frictional force is mu s into n, that is mu s, n is mg. Okay, that is static frictional force value. Suppose the brick is placed like this. This is the same brick. I keep horizontally. This is vertical. Okay. So what is the frictional force here? Fs is equal to still mu s into mg. So there is no difference between these two formulas. That is, here the area of contact is less. Here the area of contact is more. In both cases, the frictional forces will remain same. And one more point is this one more law, that is, I will write here, this kinetic frictional force value, one more point. So kinetic frictional force value, kinetic frictional force is independent of speed of the vehicle. Speed of the vehicle. Speed of the body, generalize. Okay, speed of the body, independent of speed. Independent of speed. It won't depends upon speed. So if you increase this force more and more, the body starts accelerating, isn't it? It starts accelerating. Okay. Then kinetic frictional force remains same. Okay. So if F is the applied force, F is the applied force, Fk is the kinetic frictional force, kinetic friction, it is given by Fk is equal to mu k into N, that is mu k into mg. Okay, so that is the value. Now as the applied force increases, I apply Newton's second law. So the resultant force, the body has acceleration A. So acceleration of the block is acceleration of the block. So I want acceleration of the block. So A is the acceleration of the block. Acceleration of the block. So if external force acts on the body which causes acceleration. So apply Newton's second law. This acceleration is equal to resultant force by mass of the body, net mass. Resultant force by mass of the body. Okay. So what is the resultant force? If you draw FBD of this, FBD, applied force is like this, friction opposes like this, Fk. So the body accelerates having the mass m in this direction. Let it be. Okay. So apply Newton's second law here. This is very important formula. External force F minus frictional force Fk, since these both are in opposite, minus by mass of the body. Let it be m. So this is the formula for acceleration of the body. Applied force minus frictional force by mass of the block. This is the formula for acceleration of the block. Okay. Clear this example? Okay. I will try to explain with the example. Okay. You take this. To understand this instant, I will try to explain with one example. Okay. A block of mass 1 kg, a block of mass 1 kg is at rest, on a rough horizontal surface, rough horizontal surface, where coefficient of static frictional force is 0.2 and mu k, coefficient of kinetic friction is 0.15. Find the frictional force. Find the frictional force if a horizontal force A, F is equal to 1 Newton, B, F is equal to 1.96 newtons, C, F is equal to 2.5 newtons is applied on a block. is applied on a block. Okay, this is the problem. So we have to solve this one. So solution. So this problem consists of 3 instances. Applied force 1 Newton, 1.96 Newtons, 2.5 Newtons. At these instances we want frictional force. Okay, see, so there is a block of mass 1 kg. So what is its weight? Weight mg acts downwards. So normal reaction acts upwards. Okay. So what is m? Normal reaction is equal to mg. What is m? 1 kg. G is 9.8. So a normal reaction is 9.8 newtons. So I want the applied force. Let us assume that the force value applied force in this direction. Then the friction tends to in this direction. So it opposes a relative motion. Okay, how it will act? Tangential to the surfaces of contact. So I want the static frictional force value. First you check limiting frictional force value. So what is the maximum value of static frictional force? It is given by mu s into n. Okay. So what is mu s? Static frictional force value. So static friction. First I find the static friction. That is mu s into n. What is mu s? Mu s is given as 0.2. So 0.2 into 9.8. So how much it is? It is I think it is half of that, 0.49. It is 2.49 I think newtons, isn't it? So 98 into 2 196. 98 into 2 196. So it is 98 into 2 196. So 9.8 we have 0.2, decimal is 1.96. Sorry, here it is 1.96. So you have to write here this one. The static frictional force value is 1.96 newtons. Okay, so the applied force is 1 Newton. But if case A, if A is equal to, if what is applied force, I represented with a capital F. If applied force is 1 Newton, so this applied force is less than applied force is less than limiting frictional force value. Limiting static frictional force value. Less than static frictional force value. Static friction. Then what happens? Is it block moves? Is it block moves? No. Block does not move. Block does not move. So what is the nature of the friction? So nature of the friction is static. Nature of the friction between block and the surface. Block and the surface is answer static. Static. I want its value Fs. So at that instant this static frictional force is equal to applied force. Static frictional force is equal to applied force at that instant. Applied force. So what is that? Fs is equal to, at that instant applied force is 1 Newton. So static frictional force is 1 Newton. Clear this point? This is very important point. You try to understand what I am saying. Once again I am repeating. If whether the block is moving or not, you have to check with the static frictional force value. Okay? If applied force is less than static frictional force, you have to check this condition. If this condition is satisfied, block does not move. Okay? Then block does not move. Then nature of the frictional force between block and the surface is static, and this value is equal to applied force, that is 1 Newton. This is very important points. That is case A. Okay? Now case B. So case B. What is applied force? 1.96 Newtons. What is Fs? Fs is 1.96 Newtons. So block has ready to slide. Block has ready to slide. So at any particular instant or time, block is ready to slide. So frictional force is equal to applied force, that is 1.96 Newtons. Clear? But the block is ready to slide at this instant. So here applied force gradually increases. Initially 1 Newton, then it will change as 1.6 Newtons. At this position the block is ready to slide. If 1 Newton is applied, block does not move. If 1.6 Newtons is applied, as applied force increases, the frictional force is also increases, and when it is 1.96, the block is ready to slide. When applied force is 2.5 Newtons, what happens? Now the block accelerates. Okay? So for the case B, for case C, so when F is equal to, when applied force, you find the kinetic frictional force value. So once the block starts accelerating, nature of the frictional force is kinetic. Once the block slides, nature of the friction is kinetic. Nature of the friction changes. Nature of the friction is, it will become kinetic. Okay? I want that kinetic frictional force value. It is given by mu km. What is mu k? 0.15 into n. N is mg. So that is 0.15. What is m? 1. What is g? 9.8. Okay? So what is this value? 9.8 into 1.15. How much its value? So it is you multiply that value 0.15 into 9.8. How much it is? 1.47. It is 1.47. So 1.47 Newtons. Is it increases or decreases? Check. Fs is 1.96. Fk is 1.47. Once this block starts sliding, nature of the frictional force is kinetic and its magnitude is less than static. Static is 1.96. Once it starts sliding, frictional force value decreases, that is 1.47. Now I want acceleration. Frictional force is this value. Okay? Frictional force is this. Answer for that question is over. But when this force is value, this value, when the force is 2.5 Newtons, block starts accelerating. Block has acceleration. In third case, block has acceleration. So what is that acceleration? A is equal to applied force minus kinetic frictional force by mass. So what is applied force? 2.5 newtons minus 1.47 by 1 kg. So acceleration is 2.5 minus 1.47 by how much you get? 2.5 minus 1.47. How much you get? 1.03. So you will get 1.03. Units is meter second to the power minus 2. So when the applied force is 2.5 newtons, the block slides and it has acceleration 1.03 meter second to the power minus 2. Here you have to notice one more point. What is that? See, here when force is 1.96 newtons, the frictional force is 1.96 newtons, isn't it? These two forces are equal. Then the block may slide, okay? And once the block starts accelerating, if it wants to continue with uniform speed, then these two forces are balanced. Net resultant force may be 0. Then the block may be set into motion, but resultant force acting on that is 0. Such a instant is called dynamic equilibrium. The block moves with the uniform speed. Okay, when the block moves with uniform speed, then that instant we can call it as dynamic equilibrium. So this is one example. So note, once the block starts sliding to move with uniform speed, or velocity, uniform speed, force required is answer Fk. So once the block starts sliding to move with uniform speed, force required is Fk. So here see, applied force is F, block starts accelerating, okay, block starts moving, then which frictional force is present? Fk is present. When the magnitude of these two are equal, see, N and mg cancel with each other. So what is the instant here? F is equal to Fk. So when F is equal to Fk, N is equal to mg. So that a situation is called dynamic equilibrium. We can call it as dynamic equilibrium. Dynamic equilibrium. Okay. Now, the net contact force is, the frictional force is also a contact force. Okay, suppose, see, the block is placed on this table, rough surface. So, frictional force acts in this direction, frictional force, Fs, and both are contact forces. Here contact forces are, find the net contact force. Contact forces or A, normal reaction, here normal reaction, here B, frictional force. Both are contact forces, isn't it? Both are contact forces. I want net contact force. So the net contact force I want. Net contact force is resultant of these two. So it will be in this direction. Okay, that is resultant of N and Fs. So I will extend this one like this. This is also Fs. Both are parallel, equal vectors. So I want net contact force. These two are in perpendicular to each other. So net contact force is square root of N square plus Fs square. Okay, so that is net contact force. That is, but N square, what is Fs? Mu s into N, that is mu square N square. Since Fs is equal to mu s into N, so you take N square common, N into square root of, we will write mu s square plus 1. Okay, this is the net contact force. So it is given by, R is here mg into square root of mu s square plus 1. So this is the answer for net contact force. What is R? Net contact force. That is the resultant of Fs and N. Okay. Now the angle, now I am going to define new physical quantity, angle of friction. I am going to define new physical quantity, angle of friction. It is represented with letter phi. See, the resultant one makes an angle theta phi with the N. This angle we can call it as angle of friction. This one I extend here, I join here. So this one is also Fs. This one is N. You see the triangle here. Fs is in this direction, N is in this direction, then the resultant will be in this direction according to triangle law. So these three are represented by the three sides of a triangle taken in order. Then closing side of the triangle taken in the reverse order represents the resultant of these two. Okay. So the angle between resultant, angle between the resultant of static friction, resultant of static friction and normal reaction, the angle between the resultant of static friction and normal reaction and the normal reaction, between the normal reaction is called angle of friction. Thus we can define this angle of friction. It is represented with the letter phi. So how do you define angle of friction? The angle between the resultant of static friction and normal reaction and the normal reaction. So these two. This is the resultant of N and Fs and angle N. This angle between these two is called angle of friction. So from the triangle we have tan phi is equal to Fs by N from diagram. How I got this? From diagram I got this tan phi. So tan phi is equal to, what is Fs by N? Mu s. So coefficient of friction is equal to static frictional force value. So I conclude that coefficient of tangent of, very important, tangent of coefficient of friction, tangent of angle of friction is equal to dash. So what is your answer? Coefficient of static friction. Your answer should be coefficient of static friction. Okay? Tangent of angle of friction, tan phi is equal to mu s. Clear? Take this.